Imagine staring into a mirror that doesn't just reflect light, but time itself, peering not at your own face, but into the infancy of the universe, when existence was still wrapping itself around its first breath. That's precisely what the James Webb Space Telescope was built to do. But what it found when it looked deeper than anything before it was in infancy. It wasn't the cosmic cradle. It was a contradiction, a cosmic impossibility. And what it saw, what it revealed to us, has not just stunned astronomers, it has shaken the very skeleton of modern physics. For decades, scientists believed they had a pretty solid grasp on how the universe evolved. First came the Big Bang, then a dark age, followed by the slow, methodical birth of stars, galaxies, and eventually life. The further back we look, the simpler things should be. Basic particles, faint hydrogen clouds, chaotic, unformed space. But when Webb turned its golden mirrors toward a remote and supposedly quiet sector of the sky, one of those vast black stretches where we expected little more than darkness, it captured something that should never have existed at that time. A fully developed galaxy. Not a hazy blob or scattered gas, but a complex rotating system of stars complete with spiral arms and a monstrous black hole at its heart. Not just formed, but thriving. This was not a fluke. As data poured in, more galaxies emerged from that primordial shadow, fully structured, chemically mature, gravitationally stable. It was as if the cosmic clock had jumped ahead, skipping billions of years of slow evolution and landing in an era of impossible maturity. And with each observation, one terrifying question began to echo louder in scientific circles. What if everything we thought we knew about the beginning is wrong? When the Webb telescope first captured the image of what now seems to be an impossibly mature galaxy sitting over 13 billion light-years away, it was expected to be another faint ancient smear of light barely distinguishable from background noise. But instead, what stared back was nothing short of architectural elegance. Spiral arms wrapped like ribbons of starlight, dense star clusters orbiting in harmony, and a dense core pulsing with energy. This galaxy wasn't forming. It was formed, and not just barely. It looked like something we'd expect to find several billion years into the universe's timeline, not within the first few 100 million years after the Big Bang. To understand why this is so baffling, you have to understand how galaxies are thought to evolve. In the early universe, matter was spread thin and uneven, gradually pulled together by gravity into clouds that collapsed into stars, which then grouped into galaxies over enormous time frames. But what Webb saw suggested that this entire process had already completed far too quickly. That galaxy hadn't just taken shape, it had thrived. The laws of astrophysics didn't allow this. It was like finding a fully grown, ancient redwood tree sprouting from freshly planted soil. Even more puzzling was that this wasn't an isolated phenomenon. Webb uncovered multiple examples. Galaxies across different regions of the sky, all displaying levels of organization, complexity, and maturity that were flat-out impossible according to our current understanding of cosmic timelines. And this wasn't just a glitch in the telescope. The instruments were working perfectly. What wasn't working was the framework of our theories. Once astronomers analyzed the spectral data, the fingerprint of light that reveals the elements within these galaxies, they were hit with another shock wave. Not only did these galaxies exist, but they contained the chemical signatures of elements that shouldn't have been there yet. Oxygen, carbon, even iron. These elements don't come from nowhere. They're forged in the hearts of massive stars and only released into the cosmos through supernova explosions. That process takes time. First-generation stars, called population 3 stars, burn hydrogen and helium. Then they die, scatter their contents, and eventually second-generation stars are born enriched with heavier elements. That entire sequence should have taken hundreds of millions, if not billions of years. But here they were, galaxies less than 400 million years old, showing signs of multiple generations of stellar death and rebirth. That would mean that not only had the first stars formed and died, but that the cycle had already repeated more than once. The early universe, it seems, wasn't quietly waking up. It was sprinting, forging, burning, and exploding in ways no one anticipated. And the presence of these elements raises even deeper questions, because these are not just the ingredients for stars. They're the foundation for planets, atmospheres, and potentially life. To find them so early is like stumbling across a thriving coral reef at the base of a volcano that only erupted yesterday. The timelines don't just feel rushed, they feel broken. Just when scientists thought things couldn't get more confounding, the center of one of these ancient galaxies delivered the most outrageous surprise of all. Nestled deep within its core was a supermassive black hole estimated to weigh over 1 billion times the mass of our sun. In today's universe, that would be incredible. But in the early universe, that's not just unlikely, it's cosmologically absurd. You see, black holes are thought to grow gradually. They begin as the remnants of massive stars, then feed over billions of years by consuming gas, dust, and other stars. Even the most optimistic simulations with accelerated growth models and nonstop feeding can't explain how such a colossal black hole could form within 400 million years of the Big Bang. It would be like finding a fully grown adult who was born just an hour ago. The math doesn't work. And yet there it was. The gravitational signature was unmistakable. The rotation of nearby stars, the energetic emissions, the warped space around it, everything pointed to a black hole that had skipped adolescence entirely. It didn't grow. It arrived. Scientists are now entertaining radical theories. Primordial black holes formed directly from the collapse of extreme density fluctuations in the early universe, or perhaps the influence of exotic particles or dark matter accelerating their growth. But these are not adjustments to current models. These are completely new blueprints for reality. What do you do when every observation defies the rules you've been taught? For many cosmologists, the answer is unsettling. You rewrite the rules. Because the James Webb Telescope hasn't just shown us anomalies. It's revealed a universe that seems to be behaving in reverse, where complexity comes before simplicity, and where ancient light carries blueprints that shouldn't exist. Some scientists now propose that dark matter, long thought to be a passive gravitational force, might have played a more aggressive role in shaping the early universe, forming scaffolds that fast-tracked galaxy growth. Others suggest that time itself may have flowed differently in those early moments, stretched and warped in ways we can't yet detect, allowing entire epochs of evolution to pass in what appears to us as mere flashes. And then there's the most chilling idea of all, that perhaps the early universe wasn't so different from the one we see today. Maybe complexity is not the end point of cosmic evolution. Maybe it's the beginning. As the data kept flowing, researchers began to notice something even stranger, something that had nothing to do with the brightness or the mass of these galaxies, but with the shapes they repeated. Using deep learning algorithms, scientists found that the distribution of these ancient galaxies followed a very particular repeating mathematical ratio, one eerily similar to the golden spiral. This was not just aesthetic, it was structure, a hidden geometry that spanned billions of light years, linking star systems and galaxies in elegant alignment. The very layout of matter seemed to follow a fractal logic, as if the universe was coded from the beginning with a design that echoed across scales. It wasn't just coincidence. The spiral arms, the rotational symmetry, the orbital distances, Webb's high-resolution imaging revealed that what we thought was random chaos in the early cosmos may in fact have been patterned, predictable, like fingerprints. But fingerprints of what? A fundamental law deeper than physics, or something far more disturbing? Evidence of intentionality embedded into spacing itself. One of Webb's most controversial findings came not from a galaxy or a black hole, but from the faint chemical trail left behind in a seemingly empty region of space, an interstellar void, so ancient it was assumed to be sterile. But the telescope's spectrometers detected something inexplicable. Complex organic molecules, not simple methane or ammonia, but polycyclic aromatic hydrocarbons, the building blocks of amino acids, and by extension life. These chemicals weren't attached to planets. They weren't swirling inside stars. They were drifting, aimless, and yet somehow intact after 13 billion years. This raised alarms because the implications were beyond biological. It meant that the ingredients of life had existed nearly since the beginning, not formed later in solar systems like ours, but seeded into the fabric of the cosmos almost immediately. And if that's true, then life isn't a fluke of planetary alignment. It's a feature, a constant, a thread woven through the universe from the start. The unimaginable, it seems, wasn't just galactic. It was molecular. Then came the image that threw even the most skeptical minds into silence. Deep within a cluster of high redshift galaxies, Webb detected a formation that was too perfect. 6 galaxies positioned like petals around a central object, spaced at equal distances, rotating in near synchronized orbits, like some cosmic dance choreographed with a purpose. Scientists called it the flower. And despite their efforts to explain it away as a statistical anomaly or gravitational coincidence, no natural model could reproduce its precision. It was an astronomical sculpture frozen in light from a time before Earth had formed. Some proposed gravitational lensing. Others suggested quantum symmetry left over from early universe turbulence. But a quiet few wondered aloud whether this might be something else entirely. A marker, a signpost, a calling card left in plain sight, meant only to be seen once humanity's eyes had evolved enough to perceive it. And finally, the most chilling theory to emerge from all of this, that the very act of observing these ancient galaxies might be influencing them retroactively. Known as the observer effect in quantum physics, it describes how the outcome of an event can be altered simply by being measured. But what if this principle doesn't stop at particles? What if the universe, on some unfathomable level, is responsive to attention? That by building James Webb and peering into the early cosmos with this unprecedented clarity, we didn't just uncover secrets, we woke something up. This theory, once laughed off as philosophical noise, is now being taken seriously by a fringe of physicists who see patterns in the Webb data that shift depending on how and when they are processed. Some images seem to alter subtly over time, as if the universe itself is reacting to being observed. If true, it would mean we're not just explorers. We're participants, co-authors of the very reality we seek to understand. What the James Webb Space Telescope detected was never just about stars or black holes or dust drifting through time. It was about truth, a truth so vast, so ancient, and so intricately woven into the fabric of everything that to witness it is to feel the scaffolding of reality tremble beneath your feet. We didn't just see the unimaginable. We unlocked it, not by force, but by attention, by daring to ask questions no civilization before us had the technology or the audacity to pose. Galaxies too mature, chemistry too complex, patterns too perfect, signals too aware. What Webb revealed is not simply that the universe is more mysterious than we imagined, but that it may be aware of our imagination. That perhaps for the first time in history, the cosmos whispered back, not in words, but in light, in formation, in echoes that bend across time itself. Maybe we didn't find the edge of the universe. Maybe we found its memory, and it remembered us. So now the question isn't what did Webb see? The real question is what saw Webb? If this left you shaken, if the patterns felt too sharp, the timing too perfect, the revelations too synchronized to be random, then you're not alone. Subscribe because we're not just watching the stars. We're watching the response. Turn on notifications because the next signal may already be incoming. Share this video with someone who still believes the universe is silent. Comment below. What do you think Webb saw or woke up? Applause.